team, it's Ben,
Mana,
Logan.
and we're back, and this time we are going through the microscopic structure of muscle. So we start with the muscle. Muscle is made of
fascicles,
which are bundles of muscle,
Fibers.
and then the thing that contracts inside a muscle fiber is the myofibril, little fiber, and then a myofibril is made of
Filaments.
myofilaments. So the sliding filament theory is when these filaments slide over each other when our muscle contracts. So we've got two types of myofilaments. We have
Myosin.
myosin, which is
Dark.
dark and thick, and we have
Actin.
which is
skinny,
and
very little,
And
Yep.
light.
skinny, little, and light. Good.
skinny little and light.
So remember when we drew the myofibril, we drew it and it was stripy. So those repeating series of dark and light bits that makes it striated are because the myosin is
Dark.
and the actin is
Light.
so if you line them up, we get a stripy muscle. Okay, let's start labeling. So this was our actin, and this was our
Myosin.
good. Oh, lovely, Mother. Thank you very much. Then we got different regions we want to look at. So in the middle of the myosin is the
M zone.
so the M line. Good. Okay. Now, the length of the myosin is called the what band?
A band.
Good. So A stands for a very long word. That means light can't go through it. So that's where we look over here on a microscope and it's all stripy. The A band will be the dark band in our myofibril. Okay. A could also stand for,
Aotearoa.
because in the A band, we've got thick people, and we've got thin people, and we don't mind, we love everyone. But in some parts of the world, they only like certain types of people. So, in some parts, they only like thick people. So, what letter do I look like if I'm a thick person?
An H.
Good. So, if we put our H zone in there, so end of the fin, so the end of the fin, so only thick is an H. And then other bits of the world, they only like thin people. So what letter do I look like?
An I.
Good. So from the end of the myosin, end of the thick, to the other end of the thick, so through here is our eye. And if you look, it actually looks like an eye. Alright, so next up, we've got the Z disc. So where is the Z disc?
On the middle of the eye.
Good. So the middle of the actin is our Z disc. And then we got another one over here, Z. So a sarcomere is from one Z disc
To the other.
to the other. So this is our sarcomere. Alright, have we missed anything?
When we contract the muscle.
Oh, good. Thank you, Logan. So when a muscle contracts concentrically, so a concentric contraction is when the muscle has tension and it
It gets closer.
shortens. Good. As opposed to eccentric, where when there's tension in the muscle and the muscle
It expands.
lengthens. Good. Okay. So during a concentric contraction, our myosin isn't like this. It's made of lots and lots of myosin molecules, which go like this, and they got heads on them. So there's our myosin molecule. Here's another myosin molecule. And then we're going to have them down here as well. And down here. So each myosin molecule, they grab onto the actin and then they pull it closer together. So if I pull this actin and this actin closer together, what's going to happen to the bit that's only thick?
It goes smaller.
Good. So what is the bit that's only thick?
The H zone.
Good. So during a concentric contraction, the H zone will get smaller. So here's my I band, which is only
And I.
Skinny.
Skinny.
thin. Good. Only actin, only thin. If I pull the actin this way, then the I band is going to get
Smaller.
Good. So during a concentric contraction, the H and the I get smaller. So what's the A band?
The one that loves everyone.
The one that loves everyone, Aotearoa, and it's the length of the...
Myosin.
Good. So if our myosin molecules pull the actin, is the myosin going to get bigger or smaller?
It's gonna stay the same.
Good. So during any contraction, the A band, the myosin, stays the same. Because just like Aotearoa, people may come and slide on top of it, but the length of Aotearoa doesn't change. Boom. Done.